Alright, so today we're going to have a further go with some Venn diagram questions. So, in this case, we're using the lower letters A, B, C, D, E, F, G, H as our elements, and then we have our two sets C and D, where C is this set here, and D is this set here. So the first question I'm asking is N of C. Now, N just means number of elements. So it basically asks the question, how big is this set? So let's firstly just work out what C is. So instead of saying N of C, we can say N of the set of elements, which is C, which is A, B, and C. Alrighty, since there are three things inside C, we would say that the size of it is 3. Alternatively, you could just work out what C is, see that there's 3 elements, and go, well, N of C must be 3. Let's have a look at the next one. The next one is the intersection, N, of C dash and D dash, which means not C and not D. So there's 2 ways we can do this. The visual way we can do this is, well, let's first of all highlight not C. So not C would be this area right here, which includes the elements E, F, D, G, and H. Then we can do the same thing, but highlighting for not D. So not D would include all of the elements that are not in D. Now, where we see the overlap, meaning both yellow and green, which as we can see would be D, F, and E, where they have been highlighted by both yellow and the green, then those are going to be the answers. Okay, so the answer is just going to be D, E, and F. Now, what if we were doing this without a Venn diagram? This strategy is not going to work at all. So let's try a different tactic. So you can see I've just put C up in the top left. That's where C goes. Because remember, this whole thing is in the set of C. Now, C dash and D dash. So C dash is going to be equal to everything that is not in C. So that's going to be D, E, F, G, and H. Intersection with D dash. D dash is going to be everything outside of D, which is going to be A, B, D, E, and F. Now, intersection means where they are both true. So D matches with D, E matches with E, F matches with F, and there's no other matches. So that means when I evaluate this intersection operation, I am left with just D, E, and F, because they're the only matches between the two sets. So you can see we can solve these sorts of problems visually or algebraically. Either way, we're still going to get the same answer, so it doesn't really matter. It's more about what we're comfortable with. But how do we evaluate a union symbol? Well, if I'm thinking about doing it visually, well, C is this little blob here, and D, let's do it in blue instead. D is going to be this, not D, is going to be this whole space, not including D itself. Now, with the OR operator, we are going to touch everything that's highlighted, regardless if it's in double highlighted or single highlighted. So in this case, that is A, B, C, D, F, and E. Because either they've got to be in not D, or they've got to be in C. So in this case, the answer would just be A, B, C, D, E, and F. Those are all of the elements there. But if I wanted to do this algebraically without having the Venn diagram, how about would I go about doing it? Well, let's work out what C is equal to. So C is just A, B, and C. And we're unioning it with not D. Well, not D is A, B, E, F, and D. Now for the OR operator, once we actually have the set written down, instead of only looking for the intersections, we just look for all elements. We're going to keep everything. So A, B, and C from here. We can skip over A and B because we've already highlighted them, and then D, E, and F from the second set, and that's going to give us the full set A, B, C, D, E, and F. So we just include everything, because remember, the union operator is basically a joining. It's joining these two sets together. What is everything that's in C that is also or in not D? Once you know what they are, you can just find all of the new ones and list them. We don't put them in twice for A and B, because remember, if A is in both, well, we don't put it in twice. It's still just one element. Alrighty, so that's a little bit more on Venn diagrams and a little bit of set notation. I'll see you in the next one. Goodbye.